This is 6-6 part 2. In 6-4, when we were talking about linear equations, we ran into the situation where if we had two parallel lines, we would have no solutions to that system of equations. Now, when we're talking about inequalities, that isn't necessarily true. Sometimes you can have parallel lines and still have solutions that will work. And I'm going to just take some time here to run you through kind of the three different scenarios that we run into when we have parallel lines with inequalities, and then also take you through a story problem. So let's look at this first example. So if we graph these guys, the first line has to start at -4, and it has a slope of -2, so it's going down 2/1 each time. And it's going to have a solid line because it's less than or equal to . So there's that line. Now, on the next one, it's got to start at 5. It also has a slope of -2. And remember from back in chapter 5, we know that parallel lines have the same slope, so we know that these two lines are going to be parallel. This one has to be dashed. Okay, now if we look at the shading for the first line, it's less than or equal to, so it has to be shaded below. And the second one, it's greater than, so it has to be shaded above. So you can see in this particular situation, it's just like with equations, we have no overlapping of the shading, so then we would write no solutions. So it can be a possibility. However, it's not the only possibility like it is with equations. So let's look at another one. So the first line here starts at -2. Has a slope of 3, so up 3/1. This one's got to be a dashed line. And it's greater than, so it gets shaded above. And then the second one here starts at 6. Has a slope of 3. It's also dashed. Okay, and it's less than, so it gets shaded below. And you can see that the two are going to overlap down the middle. So all the solutions to this system of inequalities would be in between the two lines. Okay? And then the third scenario that you might run into when we have parallel lines, let's look at this one. So we have to start at 6 for the first line. Up 4/1. We can also go down 4, back 1. Same thing. And that one has to be a solid line. And it gets shaded above because it's greater than or equal to. Second line here has to start at -5. Slope of 4. 4/1. It's also a solid line. And it also gets shaded above. So you'll notice on this one, the only area that they overlap is everything to the left of our first line there. Everything over here. Okay. Okay, so when we have a system of inequalities with parallel lines, they'll either have no solution, they'll intersect in the middle, or they'll intersect completely to one side of the lines. Now let's look at a story problem. So we have, at a party, Alice is serving pepper jack cheese and cheddar cheese. She wants to have at least 2 pounds of each. Alice wants to spend at most $20 on cheese. Show and describe all possible combinations of the 2 cheeses that Alice could buy, and list 2 possible combinations. Okay, so we're going to need to write several equations here to represent the situation. First of all, we have to deal with that she wants at least 2 pounds of each type. So if we call pepper jack X, okay, we need at least 2 pounds of that. So X greater than or equal to 2. And if we call cheddar Y, we need at least 2 pounds of that. So we call Y greater than or equal to 2. So there's our first 2 equations. And then she wants to spend at most $20 on cheese. And this table here gives us the price per pound. So that equation would be 4x, 4 times however many pounds of pepper jack, plus 2y has to be less than or equal to 20. So this story problem, as you can see, actually has 3 equations to it, which isn't uncommon when it comes to story problems. Now, this first one you'll have to remember is a vertical line, because it just has an x, no y. So let's label our graph first. Remember, this is pepper jack. And this is cheddar. We'll just count by 1, so x greater than or equal to 2, that's a vertical line at 2. Just numbering my graph here. So I need a vertical line. It's going to be solid because it's greater than or equal to a vertical line at 2. And greater than or equal to, well, since it's vertical, greater than or equal to means it gets shaded to the right. Okay. Now, my next one, y greater than or equal to 2, is a horizontal line at 2 on the y-axis. It's going to look something like this. Greater than or equal to, it would get shaded above. Okay, now I got to graph the third line. Before I can graph it, I have to put it in slope-intercept form, so let's go ahead and do that. So I have 2y less than or equal to negative 4x plus 20. You gotta divide by 2. So I get y less than or equal to negative 2x plus 10. So I'm going to start at 10, come down 2 over 1 each time. And it's also going to be a solid line. And since it's less than or equal to, it gets shaded below. Okay, so you can see that the only place where all 3 colors, red, blue, and green, overlap is right in this little triangular region right here. So everything in there would be a potential solution to my problem here, and it told me earlier to list 2 possible solutions for how many pounds of pepper jack and cheddar that she's going to buy. So let's see, it looks like 3 would work if she wanted 3 pounds of each. And what else would work here? I could go with 2 because it can be on the line because it's a solid line. I could go with 2, 3 as well. Okay? So that's with story problems. They get a little more complicated because you might have horizontal and vertical lines in there. But they're kind of fun. So, as always, let me know if you have any questions.